Welcome to the course on operating systems. The topic for today is protection in operating systems. There is a reason why we said that the single user systems have become very unproductive, because the program does not use the central processing unit so much, it is more with the input output devices, making the efficiency, the throughput, or in other words the return on investment a question mark. So, we have to somehow create a method by which the central processing unit, which is the costliest component in the entire computer, is working efficiently, and towards that goal we wanted to talk about multi-user system, multitasking systems. One other reason why we wanted to move into multi-user systems is the fact that the memory, which we have seen in the earlier chapter, is to be used in a manner where the efficiency of the scheduling on the CPU improves, in addition to the way we are using the memory. So, we have come to an understanding that there have to be virtual memory systems, there will have to be more than one user program currently resident in the main memory, and the way the virtual memory and the scheduler work together eventually results in a high efficiency, high throughput, very good response time, less waiting time, and overall high user satisfaction. However, what is the reason why we should believe that one user program is not interfering with what the other user program is going to do or is wanting to do with the CPU? What is the reason why we are believing that exactly the pages, the working set of a given program is what is being worked upon by the CPU, and even by a sheer accident it cannot be a working set of some other program. So, one user program must be protected from the other user program. Likewise, a user is using several resources on the computer, the program, the user, and the resources must all be protected by the operating system. So, one of the core functionalities of operating system has become protection. Protection is a term that is more internal to the operating system. The parallel term for external uses of the operating system is security. Protection is internal, and therefore, we think that it is very easy, it is all our own resources, we are managing our own resources. A simple resident monitor will be able to track which memory address is being used, which user is going to work on what resource. All these appear to be very simple, because protection as a term is more to do with the internal resources of the system. However, in practice we understand that the protection needs to be given much attention, and as we progress in this particular lecture, we will understand that there are several ways of ensuring that the user program, and the resources which the user is currently using are protected from other users. It is definitely sure that a single user system is very unproductive. We want multi-user, multitasking systems, and therefore, there have been some implementations of the principles of protection, the domains of protection, which vary from one another depending on the operating system, and the most important method in all these is what is called access. We restrict the access to the resources. A particular user can use only this much of memory, this many memory locations, can use only these resources, and they are all notified before to the operating system, because an internal characteristic of the operating system to talk about protection, the user files are protected, the user devices are protected, the way the user works with the memory locations is protected. One user is completely protected from the other user, and the simple time tested most popular method is what is called access restriction. How do we grant the access restrictions? How do we revoke the access restrictions? We have been talking about simple implementations which are indicative of what is the capability which a user can be given, what are the language based approaches for protection. This is the set of subtopics in this major topic called protection operating system, and as we keep saying, access begins with the file. The user initially, let us say, has a resource called file. Plenty of data is there, lot of data is there, and this data is in the file. Even in the last lecture on virtual memory systems, we have discussed that input data, output data, when they are coming live into the program, may occupy only limited space, but there is large set of data which is in the file, and files must be operated upon by the programs. Therefore, we talk about file first. The file is on the secondary memory. A small chunk of this file will go into the main memory as the input, and an output will also get generated. What do we do with protecting this file? It is there on the machine, on the hard disk. What do we do about it? There were days when we were talking about shared computer. Only one computer is there, all people are sharing the same computer. The directory of that particular computer is open for everybody. All people, let us say, are storing their programs, files in a common directory. We hope that they will give different file name, but then accidents cannot be prevented. Accidentally somebody deleted other user's file, accidentally somebody opened other user's file and edited it. How will we know that? How will we prevent these accidents? It is a big concern for the systems administrator when somebody says that accidentally I myself have removed the file, can you retrieve it, or there is something that has happened, I do not know why the file has changed. All these concerns become very understandable, very common when we talk about imagining a machine, a single machine. For example, the one that I am having here has all my presentations on a same CPU, and they are all sharing the same memory. It is open for all. Tomorrow it will be some other lecturer, day after tomorrow it will be some other lecturer. All of us think that there is a nice folder that is created, and this PowerPoint presentation is nicely located in that folder. Accidents cannot be averted, and when an accident comes, it may be a serious concern. Files have vanished, accidentally somebody removed the file of other person. So, explain how protection domains combined with an access matrix are used to specify the resources a process may access. One protection domain which becomes very clear is an idea called file. Most operating systems have taken the path of the Unix in telling that every file at the time of creation will have file permissions. A file can have permissions of what is called the person who has created it, the group that the user belongs to, they can have read, write or execute permissions, and the third one is others. Depending on what are the capabilities, that is what we call read, write, execute of the group, read, write, execute of others, capabilities that are bestowed on the file, the operating system assures that it will not allow any activity that is not definable in this capability. The user has a capability to read, write, the group has capability to read, others have capability to read. That means the group cannot write into that file, the group cannot execute, others cannot write into the file, others cannot execute. Likewise, the user, if he or she has only read and write capability, they cannot execute. This much assurance is given by the operating system on a file. What appears very natural is a protection on a domain called file. File permissions, file protections, they can change. There are commands which can be changed. The supervisor can come into, super user can come into picture and then say that I will help you change the file permissions. All these are borrowed from the design of Unix operating system, where file is a very important resource in the entire operating system called Unix. Many other operating systems found this a very impressive and a very interesting idea. The one domain that is appealing very naturally for protection is file. User files are protected from the usage by the group, usage by the others, and the operating system assures you in a manner where you can cross check whether this is happening or not. We can think of languages, we can think of having it in a program. In one protection model, computer consists of a collection of objects, hardware or software. Each object has a unique name and can be accessed through a well defined set of operations. Protection problem: ensure that each object is accessed correctly and only by those processes that are allowed to do so. That is the definition of the protection problem. The goal appears simple, and we have been always thinking that is very simple because users are very disciplined. They are not really intending to do any kind of a malified execution. They are busy with their problems, and that is precisely the reason why we are getting worried, because the user is so busy with his or her own problem that in the process they may accidentally end up doing some error, maybe late in the midnight, past midnight. We have been giving 24/7 computer center working, and therefore past midnight, almost half asleep, some error, some accident has occurred, and we run into serious problems on protection. Therefore, we started relying more and more on the operating system. The guiding principle is the principle of least privilege. Programs, users and systems should be given just enough privileges to perform their task. It is understandable that we have a hierarchy of the users. The super user always has maximum permissions. The principle of least privilege: it is not necessary that the top man in the organization will have all privileges. What is the focus? The central principle of protection is the fact that we need to make sure that we adhere to this idea called principle of least privilege. When we are talking about privileges given to the users based on the category of the user, the top man need not necessarily have all access permissions, like we can do anything and everything. It is not necessary. Whoever is the user, we simply ask a simple question: what are the tasks that they want to perform? Based on the task, we should grant only adequate privileges, adequate access to the resources. It is not going by the hierarchy, it is not going by the type of the user, but it is everything determined by the nature of the task on hand. If they want to access only this particular file, only that particular file access is given separately. If other files need not be accessed, they will not be given access. Limits damage if entity has a bug or gets abused. This is the best principle to limit the damage on an accidental violation of protection, which can happen. Even now it can happen, but then it may be systemic. We will trace it into the system. There is a log, there is an administrative capability into the system. The system's administration becomes very active the moment you use this principle of least privilege, and we can talk to the super user and then make sure that the least privilege, exactly necessary access to the resources is given. The system keeps track of it. It becomes very easy to limit the damage. It can be static. Once we will ask, it will always be there during life of a system. There are so many cases like that. Say for example, by default the mailbox size is 10 gigabytes. However, if there is a felt need for a given particular user, it can be made 20 gigabytes, but not more. There is still a restriction on the user. Just because the 10 gigabyte limit has been exceeded, it does not mean it will be infinite memory space that is given. There is an upper bound. We can revise the upper bound. We can make sure that it can be downsized. If somebody does not need 10 gigabytes of mailbox size, it can be made 2 gigabytes. So, all this flexibility is there, but the sooner we get all these things into the system, the systemic protection will step in, and the best principle which we can think of is the principle of least privilege. Just give privileges adequate to solve the problem on the hand, and it is not necessary that it will go by the hierarchy or rank and file of the users. Dynamic, it can be dynamic. Today it is 10 gigabytes, tomorrow it can be 100 for the same user. It can switch. We can talk about a domain called laser printers. This week I need laser printers, next week I do not need laser printers. If I am very clear, it should be fine. The early days of computing were very challenging because we were worried. Every user who was using the computer has been worried about every bit of memory, every second of the CPU time, every resource that they are accessing. They were more planned. Over a span of 7 days, a given program gets executed. Now we have plenty of computing resources, so several things have eased out, but the commitment levels of the users will become more and more challenging. One of that commitment level is we should now declare before use what resources will be used at what time, and the operating systems manager or the administrator will make sure that the resources are given. Please remember that one of the earlier lecture sessions was on deadlocks. All these are good practices which will make sure that the system will improve the efficiency, will improve the response time, will reduce the waiting time, will create an overall high grade of user satisfaction. Needs to know a similar concept regarding the access to data. So, these are the things which we have been talking about, and what we found is for data access, file access, any resource access, principle of least privilege. This is what is the guiding principle. Guiding principle is principle of least privilege. Where this is assured, the system is very efficient, it operates well. It does not mean to the system who the person is, it only matters what this user wants to do to enable what the user wants to do. It is this much of privilege, this much of access that we can grant. Rough grained privilege management, easier, simple, but least privilege now done in large chunks. There were days when we were talking about rough estimate, how many devices would you need, this week do you need laser printer. We may become a little more exacting, saying that on a given day what is your need for a laser printer. If you can define everything to the exactness, everything goes by the reservation. Particularly in multimedia networks, there should not be a jitter. The entire transmission of the video should not get interrupted because some resource in the pipeline got blocked. Then we see jitter, the quality of the transmission is spoilt. So, we want to make sure that everything happens by proper reservation, the memory, the CPU time, the input output devices, everything can be mentioned a priori. This is the best solution one can think of for efficient use of resources for which the operating system is giving guarantee. Domain can be user, process, procedure. So, every domain has a simple structure, namely we have access right, this is the object name, the rights. I have given one idea about a file. A file has access rights. Say for example, 3 categories of users can access a file. The person who has created, called the user, the group in which the user works, and others. They can have read, write or execute capabilities which can be set at the time of file creation. The systems administrator will tell every file is created by these default rights. If you are happy with these default rights, you can go ahead and use it. Otherwise, there are system calls, there are system commands which will enable you to change this default right, or if there is a problem, you can always talk to your super user, he will help you out, he or she will help you out. The rights are very clear, the domain name is very clear, the domain is a set of access rights. So, there is a domain D1, there is an object O3, O1, O2, object O3 has only read and write, object O1 has read and write, object O2 has execute. In a domain D2, object O2 is write, O1 and O3 are execute and read. So, the point is the resource may be the same, but this resource is reflected differently across different domains. For example, people cannot use laser printers from domain 2, whereas they can use laser printer from domain 1, domain 2. If domain 3, if the domain 2 is regular students who do not use a laser printer, or people who are not allowed to use a laser printer, or a very costly speaker, or a big high end monitor, we can control them remotely. Please understand that today no computer is an island, all resources are networked. one can in theory have only one machine here control multiple resources wherever they are. The network is the computer. Therefore, we have created this idea called domain, where in a given domain the user can use a particular resource, either read, write or execute. The permissions are clear, the objects are clear, the way they are created is clear, the way we use the domains is clear. Then what is the concern we are having? The concern we are having here is how to represent this. The way we represent this is an access matrix. The domain is D1, D2, D3, D4. Please look at the earlier slide again. We can talk about a domain. A domain has objects. In that particular domain, the object is having a capability of read, write or execute or whichever combination. Once again I wish to repeat, in the domain D1, the object O3 has a capability of read and write. Object O2 has only execute, whereas in domain D2, object O2 has a write capability only. In D3, it is O3, object 3 has read capability. There is one more object O4 in the intersection of the domain D2 and D3. It is possible in theory. We can take a pen and paper, classify all our resources, all which are called objects, and determine how to make them form into domains, and this is how the entire operating system views at the permissions that we have created, that is the access matrix. One simple access matrix can be arrived at sitting on the table, telling what are the domains we want to create, what are the ways in which the objects F1, F2, file 1, file 2, file 3 and printer. In this case, the objects are 3 files. Let us say F is the generic name for a file. There are 3 objects, 3 files and 1 printer. There are 4 domains. In domain D1, obviously it is very clear here, for domain D1 the file F1 has only read. For domain D4 it has read and write, and for F2 it has read. For F3 in domain 1 it is only read. So, what we understand here is that all the description that I have given is now emerging as a very simple data structure called matrix, which is known even in 10th class. A 10th class student would have worked with matrix, the representation, the rows and columns. The columns are the objects, the rows are the domains. The domains, there are 4 domains, 4 objects. You fill in the cells. The cell which is D1 F1 is only read. Now, we presume that the operating system will definitely check this access matrix, and if in domain 1 some user wants to write into F1, it will simply tell sorry, we cannot accept, you do not have necessary permission, the access rights are not there. If in domain D2 somebody wants to work on F1, F2, F3, it will say sorry, it is not possible. Least privileges, again there is a great principle to think of, it is a principle of least privileges, it can only print. Please understand, no other domain can use a printer. In this particular matrix, no other domain can use a printer, only D2 can use a printer. So, the resources are limited, that is the elegance of operating system. Using limited resources, how do you improve the efficiency? If we can draw a matrix like this, we would have definitely shown a great improvement not only in the user satisfaction and user assurance that nobody else is going to work with the resources which the user has planned to except the user, and the operating system will give an assurance, a theoretical way of proving is possible that only that is happening. Now, we move on to the use of access matrix. If a process in domain D1 tries to do operation on object must be in the access matrix, the operating system scans the matrix. It is very easy, a simple program will tell you how to work with the matrix. Every programmer begins with something called a matrix program, access a particular cell, given D1 and the object ID, it goes and checks what permissions are there. If the permissions are there, it will use it, otherwise it says no. The program to control this is very simple, very easy. We can in theory control any number of domains, any number of objects. We can keep on creating lot of domains, so that the resources are automatically segregated in the way where the principle of least privilege becomes manifest. It becomes the most important idea. Access matrix design separates mechanism from policy. The policy is dictated by the user. If you are happy with this kind of a domain, you are happy. If only D2 can print, all other domains are not able to print, and if all users are happy or majority of users are happy, we will go ahead with that. So, they have a way of telling that so many times the access was blocked, so many times the operating system is coming in the middle and say that no, it is over, the permissions are not there. So, in consultation with the systems administrator, these policies can be determined, and the mechanism is simply to represent the access matrix and go ahead with a small code that verifies this object matrix, this access matrix. So, we have domain objects. The domain itself can be an object, that is, from D1 you can switch to D2, from D2 you can switch to D3 and D4. So, for accessing a particular printer, we should understand that there is a need for moving from one domain to other domain. We should be able to switch from D4 to D1. There is a switch. The user is not statically fixed to any domain where the resources are there. So, what we do is have an access matrix. The access matrix is a very simple data structure. In the earlier slide, we have seen that there are this many rows and this many columns as I am drawing. However, we understand that if that is all is the operating system going to permit, a user and a resource that got locked in D2 will have problems with the resource when it is in other domain. So, what we do is we have extended the matrix and said that there will be a switch between from one domain to another domain. From D1, one user can switch to D2 and take a printout, otherwise he can't take a printout. He or she cannot take a printout. From D1 there is no print capability, from D3 there is no print capability. So, what we have done is if somebody wants to take a printout from domain D1, they have to definitely switch to D2 and take a printout and come back. Printing was very expensive for quite some time, and therefore, only one domain was assigned to any printer. You will have to take special permission to switch. If the operating system has had the way of switching defined, then it is fine. From D4 you can switch to D1 and access what is called, it is the same from D1 to D4, it is more or less read, but once D4 has switched to D1, they cannot write into the files. In D4 they can write. Likewise, from D1 they cannot write into file F1 and F3, whereas if they switch to D4 like this, use this particular row, this particular cell, switch to D4, they can write into read and write temporarily, it can be read and write, and we can move into D1. The way in which we have been talking about is once again a matrix, set of domains, set of objects, execute, read, write. We can have copyrights, we can talk about many ways in which this access matrix with owner rights, we can have an owner, that is what we have been talking about, the user, the owner, group, others. A file, the person who has created the device can be called an owner. We can have owner will have many permissions, owner, group, others. These are the nice ideas which are borrowed from Unix. By far the protection mechanism is very simple, elegant on the Unix lines, and most operating systems use the same method. We talked about a switch control. Printer will have a control, it will document what is printed, for how long the printer was there, which user has used it. There are many comparisons. Do you want to have exactly one access table, one access matrix, or do we have multiple access lists, multiple capability lists? The implementations differ. If we have only one access matrix and that memory location has been corrupted, we will not be able to use any matrix of any cell, any user, any resource. That is a big danger. So, what we have done is that corresponding to the group of users, corresponding to a set of users, we have created multiple lists. In the case of damage, we need to limit the damage, that is when we are good systems designers, and that is exactly what we are trying to do. We do not have one consolidated big table of so many users. Today every computer system has thousands of users all over the network, anybody can access any resource. So, access list is a simple way in which we can localize adequately and limit the damage. Damage limiting is very important, and what we talk about is all towards that. Many comparisons are there, lot of textbooks talk about wonderful comparisons between all these implementation methods. Protection can be applied to non-file, and we have a control, we have access control lists which tells that this particular set of users can access only this much of a resource, they cannot access other resource on other machine. We can use the super user permission or simply say that last 10 minutes this resource was with me, next half an hour it will not be with me. Last 1 hour I have been trying to understand how to use this, next 1 week I will not come back to these resources. The reservation of the studios is all done systematically. We have a capability, we have a revocation, we can alter this. One good example is Hydra, which talks about what capability is given to what user, what resource, rights amplification. Can I say that temporarily we have some additional rights for next half an hour, after that it will go. These are some good implementations. Cambridge CAP system talks about data capability, who can access, who can work with the data, that becomes very important. Protection in Java, I have talked about Unix, talked about many things. Language based, Java itself has fantastic packages that talk about protection, best handled by the Java virtual machine. We talk about stacks, and then we simply tell that today protection is available across all resources in this method of access matrix. We localize the damage, two principles, principles of least privilege, access control list which limit the damage, not one very big matrix which can blow off everything, access control list, segregation of properties, segregation of file permissions or domains and objects. By segregating we are limiting the damage. Many implementations are there, as I spoke, Unix, Windows, Hydra, CAP, and then language. Java has great packages that will give you wonderful protection. Java's load time, Java virtual machine is a sandbag model, everything comes into the virtual machine, everything goes. The idea of virtual machine is so central to cloud computing that it is better to understand that even at language level we can program protection, not only at the system level. Application will also take care of the protection. Thank you.